Hello and welcome. In this video we are looking at atoms and radiation, and in particular we're looking at a process called nuclear fission. Now, to begin with, this is a nuclear power station, and this is what we usually associate nuclear fission with. Nuclear fission is a process that generates heat, and that heat can be used to generate electricity inside, for example, a power station. Now here's an overview diagram of what goes on. Deep inside the power station, we have what's called the core, and in the core are the nuclear fuel rods. So these are the fuel rods in orange I've drawn here, and we usually use one of two types of element that we can carry out these reactions with in order to produce our heat. And those substances are either uranium 235, or the other one is plutonium 239. And these numbers actually represent the mass numbers of the two elements, but these are the two that we usually use, and we call these fissionable elements or fissionable substances. Anyway, we have the fuel rods in the core of the power station, and this generates the heat required to heat water, turn that into steam. That steam then goes through what we call a heat exchanger to heat more water. That water turns into steam also, and that then goes off to turn turbines to generate electricity. You don't need to know huge amounts of detail of this nuclear power station. We've covered it a little bit in Unit P1, but for now that's all you really need to know about what the power station does overall. You need to know, however, the details of what goes on with our nuclear fission reaction. So let's have a look what goes on with that. Now, to start off with, we have our fuel rod. So I've just kind of drawn one from the previous diagram. It's a fissionable element, and we said that was either uranium or plutonium. And what happens is we can work with the nuclei of those of either of those elements, and we can fire a neutron into the nucleus of one of those elements. So let's pretend we're working with uranium 235. Here we have the nucleus of one of the atoms, and here is a neutron, and we can fire this neutron into the nucleus, and you can see what then happens. A neutron is fired at a relatively slow speed into a nucleus of the uranium atom, and what happens then is the atom actually splits into two smaller nuclei. It releases a certain amount of energy, and it also actually releases, as you can see on the right hand side, 3 more neutrons. Okay, so that's very important, those points there. We have the release of energy, we have 2 smaller nuclei, and you don't need to worry about the names of those, of which nuclei they are, and we have 2 or 3 more neutrons released. And those neutrons can then go off and actually do the same thing as our initial neutron did in our diagram. They can go off and split further nuclei. So let's have a look at what that might look like in an overall reaction. So we start off with our our neutron as we did previously, and we can then slam that into a nucleus of a uranium or a plutonium atom, and as you can see we have energy released and 3 more neutrons. Now those neutrons can then go off and smash into 3 nuclei each themselves, or sorry, 1 nucleus each themselves, and they will then release the energy, 2 smaller nuclei each, and then more neutrons. So if each of these release 3 neutrons, so I've got 9 neutrons released here in total. Each one of those 9 can then go off and hit their own nuclei of other atoms, and we get a further reaction going on with many more nuclei. You can imagine that this would grow very, very rapidly, and the amount of energy released would be huge. This is actually called a chain reaction, because we start off with a one nucleus being broken in 2, or broken down into 2 smaller nuclei, and then it proceeds in the way that we've just described. And this is a reaction that can release huge amounts of energy, and it's done by splitting nuclei of uranium 235 or plutonium 239 in order to release all that energy. Now this is a reaction that could go out of control, but it has to be controlled, and therefore the amount of neutrons that are released are usually either increased or decreased in the reactor using substances that can absorb these neutrons if the reaction is going too fast, and if the reaction is going a bit too slow, those substances can be removed to allow more neutrons then to go off and cause these fission reactions. Okay, so you should be able to sketch, or at least complete a sketch of a diagram that looks like this. Remember, at each stage there is energy released, two smaller nuclei produced, that means of another element, and also 2 or 3 neutrons which can then go off and break down the nuclei of other atoms present. Okay, so that's an overview of nuclear fission. Hopefully that made sense. I'm just about done for this video. Thanks for watching, and I'll see you again soon.